This kind of problem is called a binomial expansion problem. What it means is you've got a binomial, two names, binomial name, two names, a two-part expression in parentheses to an exponential power. And the trick will be finding the coefficient for a particular power. Sometimes they're a little bit more complex than this. I'll show an example at the end. But for right now, let's just focus on this one. Um, let's see. This is all about Pascal's triangle. Pascal's triangle is the one where you just use the sum of the two coefficients, the two ones, to figure out the coefficient of the term a plus b, right? This row is the a plus b to the first power. The top is just a plus b to the 0 power, right? A number to the 0 power is 0. The third line, a plus b squared, right? In parentheses, squared. We know from from lots of experience with the FOIL method, that's a squared plus 2ab plus b squared, right? Look at that. 1a squared, 2ab, and 1b squared. That's what we're talking about. So if we have 2x plus 5 to the 8th power, and we're looking for the thing with the 5th power, right? How are things going to go? Now, I could go ahead and do the 3rd power, and the 4th, and the 5th, and the 6th, and the 7th, and the 8th, but that would take far too long, and there'd be too much opportunity for arithmetic errors, and it would simply take too long. So what I'm going to do is give you the concept for what's going on here. Let's take a look at that. This is in the a plus b to the 4th power row. Look at that coefficient 4. Now, where does that come from, right? What's the coefficient involved, right? The first one will be a to the 4th, 4 powers, yes, a to the 4th, and no b's. The second term that has a coefficient of 4 will be a to the 3rd and a single b. I'll write the first power to help us remember. But think about it. This is kind of like the FOIL method, right? In the FOIL method, we literally had A, B over here, and then we had BA over here, right? The outers and the inners actually started out in the opposite order, but we just combined them. Look at this 4A cubed B to the 1st. There are actually 4 ways to have 3 A's and a B, right? There's what if we had the 3 A's first and the B? There's what if we had 2 A's first, a B and then an A? What if we had an A, a B, an A, and of course the last one you can probably predict. I'm going to write down B, A, right? There are 4 ways to write down 3 A's and a B. And we add them together, right? We don't care about the order in the end, so we use 4. Well, not caring about the order, that's exactly what a combination is. So think about the next one. Why is there a 6, right? Why is there a 6 in front of 2 A's and a B, right? A, B, B. Why are there so many different ways to put 2 A's and 2 B's out of 4 when we don't care about order? Well, Remember, you know about counting principles, right? How many ways are there to pick two A's out of four things if you don't care about order, right? How many ways are there to get three A's out of a B? I mean, out of four things. How many ways are there to get one thing out of four if order doesn't matter, right? That's just a combination question, right? So the 4 over here came from combination. There are a total of 4 powers of A and B, and we were interested in the power, the first power. There's 1B in there. For this one, right, there's 2 B's. We're going to have B squared, and again, we're going to have 4 powers. So the number here should be combination 4, 2. You punch that into your calculator, or you use the formula if you've decided to memorize it, and you'll get the 6 that we know is the answer from Pascal's triangle. And here's the most fun thing that goes on here, right? If we think of A and B as random choices, and we think of all the paths to get from the top to the bottom, or wherever we're going, right? How many paths are there to go here? Well, you could fall left, 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 right. Falling left is getting an A, falling right is getting a B, right? Or you could have gone left, right, left, left. There's the second way. Or you could have gone left, left, right, left. There's another. And then the final one would have been right, left, left, left. I'm just replacing falling left and falling right with the locations of A and B, right? There are 4 ways to get down there to the 4, right? That's counting the number of ways to get there. Because really, when I fall down, I can only do so many lefts and so many rights to get to that location. And again, order doesn't matter in the end. It just means we wind up in the same place, right? 1 right out of 4. How many ways are there to get 1 right out of 4 choices? Combination 4, 1. Order doesn't matter. How many ways are there to get 2 rights and 2 lefts when you're doing 4 choices, randomly choosing between, when you're doing choosing out of 4? Combination 4, 2. Order doesn't matter. So there's gravity involved in underlying the creation of Pascal's triangle. And there's the idea of combinations because of that gravitational feel of just, falling randomly left or right. I think there's something called pachinko and maybe a meme that involve this stuff, but I don't quite know what I'm talking about. How do we solve this particular problem, right? We want x to the 5th, right? Let me switch color. I'll switch to blue so we know we're back to this problem. All right, we've got the 8th power, right? We know that when we figure out our combinations, right? This one, right? When you go 1 in, you did combination 4, 1. When you go 2 in, you did combination 4, 2. And you were in the 4th row because you had 4 powers, all right? So we're in the 8th row. So we definitely know that we need combination 8 something, right? But the question is, what's the something? Well, let's start writing it out, right? You've got the 2x plus the 5 to the 8th power, right? Your first term, the one that goes left 8 times, that goes 2x 8 times, well, that's going to be 2x to the 8th power with a coefficient of 1. There's only one way to go to pick 2x all the time, to fall to the 2x direction all the time. And then there's, well, we know combination 8, 1. There's 8, right? That's combination 8 with 1 ways to fall left 7 times, right? 2x to the power 7. And then that would be 5 to the power 1. Well, now we can figure out the pattern, right? We see that, let me switch color for vividness, right? This has an x to the 7th in it. This has an x to the 8th in it, right? The next term will have x to the 6th, and then x to the 5th. Aha, that's the one we want. And remember, it was combination, right? When we went one step, it was combination 1, 4, 1. If we went 2 steps, combination 4, 2. So how many steps do we need to get to from the beginning to x to the 5th? 1, 2, 3. Combination 8, 3. Right? Really what we were looking for is we know that this term is to the, we know we have 8 powers, right? We only want 5 to be on the x. We want 3 to be on the other thing. So we do combination 8, 3. P.S. If you'd like to do combination 8, 5 instead, it's the same number. You can reason it through either way. I actually prefer to think about it as 8 combination 5 because it makes it easier to track that exponent. Some people like counting the hops to get there, so they prefer combination 8, 3. I'll do combination 8, 5 because I know that gives me 5 powers of the first thing, right? So that's C8, 5 times, there's the 2x to 5 powers. Sorry about running into the other part. And then there's the 5 to the remaining powers, right? We have 8 total powers, so we have 5 to the third. So combination 8, 5, you punch into your calculator, you get the number, right? That's a number from your calculator. 2x to the 5th is 2 to the 5th, x to the 5th. 5 cubed is 125. 2 to the 5th is 2, 4, 8, 16, 32. I was doubling on my fingers. So 32 times 125. So I guess what we get is combination 8, 5. Again, calculator work. We could multiply 32 by 100 to shorten things up, or we could just, do it on the calculator. It doesn't matter. C8, 5 times 4,000. X to the 5th. So I guess the final thing to do is to punch C8, 5 into the calculator, or if you have the formula memorized, use that formula. I tend to recommend you learn how to use your calculator because I prefer students not to fill their minds with formulas, but instead to fill their minds with problem-solving techniques and conceptual understanding. In any case, that answer is 28. C8, 5 gives you a 28. So the final answer is, 56. 224,000. X to the 5th. So that is the coefficient of x to the 5th. All right? It's all about counting those exponents, figuring out where you are, and then realizing, oh, combination, what row am I in, and what exponent am I using? I promised I'd talk about slightly more challenging items. So here we go. What if they do something seemingly bizarre, like what about I'm picking the 3 just so we can practice with numbers, but there's 3x squared. Sorry. 3x squared plus, oh my goodness, 1 over x. Let's make that 4 over x. Put it in parentheses. Let's make it to Oh, the 12th power? Sure, why not? And they want the constant term. They want the constant term, right? Isn't this going to be like really hard? Well, other than the 10% of items that they make really hard on purpose, in other words, you're not supposed to have a kind of technique you've learned. You've got to apply new thinking to it. Other than the 10% of items that feel like that, almost everything should be either a direct application or a slight generalization of something you already know. So if you know binomial, if you know this is a binomial expansion problem, you see that thing and thing to the power 12, then what they ask you must be some combination of those powers. So start thinking about it. Where would we get x to the 0, right? Well, think about what we're dealing with here. This is really x squared, and this is x to the -1, right? So before, on the other slide, we were dealing with, right, powers of 2x and powers of 5. The 5 didn't contribute anything to the powers of x's or take away. But on this slide, x to the -1, well, that's going to take away powers. So what you want to do is figure out how many of these 3x's, what power of 3x squared would balance out powers of 4x to the -1. And of course, you've got to split up the 12 powers. You know, you might have to do some guess and check. You start with 6, you know, and go, whoops, 6 is too many in the front one because there are 2 each. So pretty quickly, whether by guess and check or just noticing the ratios, you would get the 4th power of the first term and the 8th power of the last term, right? And then we would know, oh, 3 to the 4th, x to the 8th, and 4 to the 8th, x to the -8th. And of course, the x to the +8th and -8th cancel each other out, and you get 3 to the 4th, 4 to the 8th. But that's not the answer. Remember, that's just the a to the 4th, right, times b to the 8th. Remember, there's always a coefficient in front, right? There's a combination coefficient in front, C12 something, right? So really, we want to multiply here by the correct combination. Now I'm going to try to reason it through without using, you know, a big giant triangle or even drawing anything in the triangle. Remember, it's combination. It has to be 12, right? And you have to choose, or, you know, you have to fall left, fall towards the 3x squared 4 times. No? Combination 12, 4, right? 4 times you have to fall to the left, get powers of 3x squared. 4 powers of 3x squared. So 4 out of those 12, order doesn't matter, right? Those 4 powers of 3x squared could be first and second, and fourth and fifth, first, second, third, fourth, 7th, 8th, 9th, 10th, 7th, 8th, 9th, 10th, right? That's 4 of them, right? They could be anywhere. Order doesn't matter. Combination tells you how many ways there are to do that. So again, I'm going to leave it at this. That's all there is to it. Well, punch it into your calculator. Unless you notice that it's, you know, left in combination format on multiple choice. Combination 12-4 is something you do on your calculator. So is 3 to the 4th, so is 4 to the 8th, so is multiplying everything all the way through, right? That's it. All you needed to realize was, oh, they want the constant term? They want the x squared to balance with the x to the -1. Oh, that means I need 8 of these and 4 of these. So I have +8 and -8, so they're gone. The 4th power applies to the 3, the 8th power applies to the 4, and because this is the 4 hops in, Let's do combination 12-4. Another way of thinking about it without the graphic is I had to choose 3x squared 4 times out of 12 choices, but it didn't matter where I chose them. The order didn't matter, but I had to choose 3x squared 4 times out of 12 choices. So that's why it's C12-4 as the final multiplier. Any other problem is going to be a variation of these two. This one was actually a variation of the first one, just a little bit hidden. Now they can't hide anything from you. You'll just figure out how many powers of the two parts do you need, and then go combination, use the big power in front, and then figure out how many times you needed to choose that first term. 4 times, okay, C12-4, or whatever the numbers might be.